All right, we just talked about independent sets, and now it's time to talk about dependent sets. All right, so imagine, if you will, that you have 5 female cats and you have 3 you know what? Even I can't deal with this. Let's switch it. 5 female cats, 3 male cats. That's better. Now, in addition to those cats, we also have 7 female dogs and 4 male dogs. So now let's talk about what the probability would be of a cat. So if I wanted to figure out the probability that if I chose one of these animals at random that it was a cat, I would first need to figure out how many cats there were total. Everybody wants to be a cat because the cat's the only cat who knows where it's at. But in this case, there's only 5 plus 3, the 5 female and the 3 male, which is 8 cats. And then we have to add up all the animals together. 5 plus 3 plus 7 plus 4, which is 19. Meaning the odds that you have a cat, if you randomly choose one, is 8 out of 19. But let's say that we weren't worried about it being a cat. What are the odds that we get a male? Well, there are 3 male cats and 4 male dogs, so we would say 3 plus 4, or 7 out of 19. But what if we said we wanted to have a cat or a male? Well, we would take these 7 male animals that we already knew of, and then we would add the 8 cats that we talked about in the first example. 7 plus 8 is 15. 15 out of 19, is that right? Well, that doesn't seem right to me. There seems like there are too many female dogs for that to work. So what we have to do is we have to take into account that when I talked about cats or males, both of those sets included the male cats. So we have to take out 3 of the 19, meaning 7 plus 8 is 15, but minus 3 gets us 12 over 19. So what we learned there is whenever I'm trying to figure out the odds of 2 intersecting circles, the odds of it being either one or the other, so both of them, is equal to the sum of one, the probability of one, plus the probability of the other, minus the probability of both together. Now, what if we had independent sets like this? Well, in an independent set like this, you'll notice that the intersection is 0 because they don't intersect. Meaning instead of saying the probability of A intersect B, we might as well be saying minus 0, which just doesn't exist. Meaning when we have independent sets, it's just the probability of A plus the probability of B. And that is dependent probability.